Ignition sequence start.
Good morning and welcome to Mission Control Houston and the International Space Station Flight Control Room. We hope you're having a very happy new year. Today, the team of specialists on duty here, is kicking off 2020, keeping an eye on the space station systems and working with the Expedition 61 crew members as they wrap up the last tasks on their agenda this week. On Christmas, Commander Luca Parmitano and his crewmates marked 3 months together on the space station and saw themselves a part of many of the year's biggest spaceflight accomplishments. As we venture into a new year, let's take a quick look back at those 2019 space highlights.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Dan Hewitt. What a way to end this decade in spaceflight. Boeing's CST-100 Starliner successfully returned after its first voyage to outer space. The mission started with a smooth ride uphill atop an Atlas V rocket, but experienced an issue shortly after separating. After flight controllers righted the spacecraft and put it in orbit, it was determined they wouldn't be able to successfully rendezvous and dock with the space station. But resolute to still accomplish as much as possible on the demo flight, teams executed a number of checkouts before guiding the capsule to a picturesque nighttime landing in frigid White Sands, New Mexico. It was a thrilling end to a jam-packed year for the International Space Station. In addition to Boeing's first Starliner flight, SpaceX conducted their first flight to and from the International Space Station earlier this year with their new Crew Dragon vehicle. Both flights continue to push us forward to once again launching crews to the station from America, with 2020 lining up to be the year we make it happen. Throughout the year, we saw 3 crews fly to the station on the Russian Soyuz, where they performed 11 spacewalks and welcomed 9 cargo vehicles from Northrop Grumman, SpaceX, Russia, and the Japan Aerospace Exploration Agency. And between it all, they worked on hundreds of experiments and technology demonstrations that benefit humans back on Earth and lay the groundwork for our mission to land the first woman and the next man on the moon under NASA's Artemis program. With all those accomplishments in the books, 2020 is poised to be a hallmark year in station history. We'll hit the ground running in January with spacewalks to finish battery upgrades and work on the Alpha Magnetic Spectrometer. While back on Earth, SpaceX will launch Crew Dragon on its in-flight abort tests, one of the last major tests before putting humans on board. NASA astronaut Christina Koch will come home in February as the newest record holder for longest continuous spaceflight by a female astronaut, an inspiring end to her first mission. Then stay tuned for the first flights of astronauts with our commercial crew providers Boeing and SpaceX, the first time we'll send a crew to the station from the Florida coast since the space shuttle retired in 2011. And on November 2nd, we'll mark 20 unbroken years of humans living, working, spacewalking, experimenting, and flying in humanity's home, low Earth orbit. And that will do it for us in 2019. Thanks for following along and sending in your questions using the hashtag AskNASA. We'll see you next year.
As Dan mentioned, there was an extra big milestone of spaceflight achieved to close out 2019. On December 28th, Christina Koch broke Peggy Whitson's record for the longest single spaceflight ever by a female astronaut or cosmonaut, at 288 days and counting. Her mission is scheduled to last until next month, racking up almost 330 days total. Koch says the concentration and control she learned mountain climbing helped her prepare to be an astronaut and to make that climb to space for her first mission to the International Space Station.
I first got involved in rock climbing actually in college. My college, North Carolina State University, offered rock climbing as a PE class. So it sounded really exciting, maybe a way to kind of get outside and have a little adventure. When I first got started, I liked more the physical challenge. That's what it was about. And as I kind of advanced in the hobby and got more technical, I found that I really liked other aspects of it, like the equipment, the gear, the physics of the system that you have to use, and also the partnership aspect of it. It's really like a team, because when you get into some of the higher levels of climbing and different types of more technical climbing, you really rely on your climbing partner. We train for spacewalks in a giant pool that's called the NBL, which stands for Neutral Buoyancy Lab. And it's a pool that's large enough to fit a full-scale mock-up of the International Space Station. So in that, we simulate everything like we would on a real EVA, including egressing out of the airlock, your safety tethers, and your local tethers that you would work when you're at a work site performing the job. So all of that is just very similar to the concepts of rock climbing. So during my astronaut interview, the most memorable question that I had from the interview committee came from Peggy Whitson, who, as you know, is a famous astronaut for having the longest time in space. She's done many, many spacewalks. She's a hero of mine. And she looked at me and she said, "When you rock climb, have you ever been scared?" And I felt like she was seeing right to my soul when she asked that question. And I feel like the answer to that question was absolutely, I have been scared. And that's when I really kind of found the fact that turning that fear that you might be having into focus is so important. And I think that's what she was drawing on when she asked that question. So that was a pretty profound moment in my selection process. I'm Christina Cook, and I'm an astronaut.
In honor of her accomplishment, last week people from all over the world took to the internet and to the television to send words of encouragement and congratulations to NASA astronaut Christina Cook. She even got a special greeting from two women who've been to space a long time ago in a galaxy far, far away.
Hi, I'm Kelly Marie Tran.
And I'm Naomi Aki.
And today we're here to congratulate
Christina Cook. And we hear that you are breaking the world record for the longest duration of spaceflight.
By a woman.
Yes!
Yes! Girl power. That's incredible. Yes. We're so inspired by your work.
Yeah, and everything you're doing and what you're doing for science and what you're doing for women.
And for the world.
And for the world. Thank you. Thank you so much for your efforts.
We want to be you.
We really do. But we can't, because you are you, and you're the best at being you.
Yes, yeah.
Congratulations.
Congrats.
Christina's long-duration spaceflight is one way NASA is learning more about how to take humans farther and farther away from Earth. The International Space Station also allows engineers who are developing new spaceships work out the systems that will support the human needs of the astronauts on those big journeys. Systems such as those that will provide clean water. In this installment of this demonstration video series, astronaut Drew Feustel discusses the water recovery system used to recycle crew wastewater for consumption.
Hi, I'm NASA astronaut Drew Feustel. Welcome to the International Space Station. On our station, our water recovery system is vital to our mission and our survival. Want to know why and how we recycle and filter our water? Let's go. We use water recovery and filtration because it is expensive to launch resupply missions, and the weight of the water is a problem as well. Think about the weight of a single bucket of water. Can you imagine the weight of water for a month's supply for 6 people on the International Space Station? What about the water for a year or more when we leave low Earth orbit for deeper space missions? That's a lot of water, and bringing it with us is not very efficient. On station, we recycle wastewater to get fresh drinking water. This recovery and filtration process includes our urine, moisture we exhale, and sweat, along with the water we use to bathe and shave. It works like this. When we use the bathroom, urine is collected and pumped to a distillation assembly. The assembly spins, pulling the urine to its walls. The urine is heated to evaporate water from the waste and then condensed in the outer chamber to form distillate. Next, the water is pumped to a tank where it is joined with the water recovered from cabin air created by crew sweat and respiration. Down the line from there, odors and any other contaminants are removed with heat. Then iodine is added for microbial control. Our water is checked often to ensure it meets water quality requirements. It is also monitored closely for bacteria, pollutants, and proper pH. The pH scale ranges from 0 to 14 and is a tool used by scientists to measure the strength of an acid or base. Our water is required to be in the 6.0 to 8.5 range. The end result of the entire process is clean drinking water that we get to enjoy every day. The recycled water on the space station is sterile. There's no odor or bad taste. You've seen that water recycling is critical for long-duration missions, such as here on the space station, and will be for future trips to the Moon or Mars. Be sure to check out the activity connected to this video so you can learn more about water filtration. Thanks for learning with me, and I'll see you next time.
Supporting astronauts' needs while they're off the planet is just one of the International Space Station's big missions. Along with that, the station promotes international cooperation, it serves as a home for scientific research that can't be done on the ground, and it functions as a testbed for future technologies that we'll need to support our plans to explore farther than before in the years to come.
Making space for technology development. Presented by Science at NASA. The International Space Station, or ISS, is Earth's only orbiting laboratory. That's important because it not only allows us to conduct research that benefits all of us on Earth, it also provides the only microgravity environment in which we can test technologies critical to our deep space exploration in the near and far-term future. Here, engineering models can be validated, and new technologies and systems for future missions can be demonstrated, without risk to crew members. Historically, the Mercury program enabled the Gemini program, which in turn enabled the Apollo program through technology and systems advancements. Today, the space station is giving us a similar experience in long-duration spacecraft operations, and serving as a testbed for new technologies and upgraded vehicle systems, which are enabling future missions. Dave Horniak is NASA's ISS Technology Demonstration Research Portfolio Manager. He notes the ISS lets us demonstrate that a technology works as intended in a spacecraft environment. Demonstrations on the space station inform operators and flight crews how the system operates, proves interoperability with other systems, and demonstrates system safety and reliability. There are many technologies and capabilities that need to be developed as we move forward to the Moon and onto Mars. For example, researchers have recently tested a new design of solar array that will be used on the first module for the Deep Space Gateway, our future space station that will serve as a home base for astronaut expeditions to the Moon. Solar arrays in operation right now need to unfold before becoming active. But new designs allow future solar arrays to roll out and also retract. They were tested for strength and durability on the ISS and were designed to be more compact than current rigid panels. NASA's Orion Multipurpose Crew Vehicle is a 4-person exploration craft designed to take astronauts farther in space than anyone has gone before. Its backup navigation system uses a new technology that is optically based. It captures images of the Moon or Earth and based on their size and angle, an algorithm determines Orion's location. These optics can't be tested on Earth because our atmosphere would distort the images enough to make the algorithm inaccurate. Aboard the ISS, however, the algorithm was confirmed to work properly. A secondary benefit is the system was tested at spacecraft speed, making for a realistic navigation scenario. As people travel deeper into space, they'll need solutions to a variety of safety challenges. For instance, if a fire breaks out, how fast can it grow and spread in a microgravity environment? NASA's Spacecraft Fire Safety, or SAFFIRE program, has already conducted a series of experiments on 3 ISS cargo vehicles to measure flame growth, oxygen use, and combustion products. Results are helping to improve spacecraft fire detection, response and extinguishment, and crew protection. Ultimately, says Hornyak, technology and operations demonstrations occurring on the ISS today are guiding our planning, reducing risk, and providing capabilities to enable future exploration missions. For more inside information about the tech being tested aboard the station, visit www.nasa.gov/ISS-science. For more on the science of space exploration, visit science.nasa.gov.
In 2019, we celebrated the 50th anniversary of the first human footprints on the Moon and all of the scientific achievements it took to accomplish such a feat. As we move into the new decade, NASA's Artemis program will continue to expand on those achievements and open the door for humanity to live and work sustainably on another world for the first time. First the Moon, and then on to our next stop in space, the planet Mars. Actress Kelly Marie Tran is back to tell the story of how we are going to put the first woman and the next man on the Moon by 2024.
Between 1968 and 1972, America launched 9 human missions to the Moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the Moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the Moon. Approaching the Moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, The Artemis missions will take advantage of a different approach, pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
According to reports from the select folks that have had the chance to leave the planet and work on the space station, the experience of seeing Earth from 250 miles up is a profound one. And some of the lucky astronauts who have been to the International Space Station multiple times say they see more and more details of the planet and of space beyond with each opportunity. Astronaut Don Pettit, a 3-time visitor, is a good example.
I thought I knew what the Earth was all about just because I'd looked at it with pictures and video and all these things. And it's like seeing some travel log in some exotic place on Earth and calling that your vacation, right? We do not do that as human beings. We want to physically go to these places because the experience is different. And it's the same thing when you go into space and you look at Earth. You know intellectually what Earth is like from space because we've all seen the pictures, but it's not being there. The human experience aspect of space doesn't come until you can relax a little bit. Now, that happened for me when I was taking my spacesuit off, and I remember floating up to the flight deck, and you look at the overhead windows, and Earth was there, and it was such an intense blue. It was somewhere over the oceans. And it was an intensity of color that no photography, no video, no movie, no film can capture. You can parse more and more details out. When you first look at Earth, you may say, wow, that's a continent. And then you look at it again the next day and you say, wow, there are mountain ranges. And then you look at it again the next day and it's like, oh, I can see synclines and anticlines in the geologic structure. And oh, there's the rain shadow effect, and on and on and on. So the more time you have to look at Earth over a long period of time, the more you can see. So there's more to see in space than just looking at Earth. You look out at the cosmos, and there's many things in the cosmos that are noteworthy to gaze at it. For example, the Magellanic Clouds. Those show up really bright and vivid because you don't have atmospheric scattering. You can see Andromeda. It's a little fuzzy spot on a really, really dark night with good vision. You can faintly make out Andromeda, but in space it just stands out because the contrast is so stark. So there's all kinds of other things to see. There's the moon. It goes through its phases. The angle that the moon makes when it rises relative to your spacecraft changes with time. It's almost like your spacecraft itself becomes a giant astronomical machine, and it's like, okay, the moon was rising over here 2 weeks ago and now it's rising over there, and why is that? And then you think about the orbital dynamics, where we are in our solar system, this and that, and then it all makes sense. So there's so much to observe, more so than just planet Earth. Yeah, I think it's important to share our experiences with all the people who, as of today, don't have a chance to go into space. But the more people that we can get off of this planet to have these kind of experiences, the more growth you will see in ideas, and the viability of your culture will increase.
If you'd like another look at the stories we featured today, check us out on YouTube and Facebook at those addresses right there on your screen. And while you're there, take a look at all the other cool stuff you'll find about NASA and America's human spaceflight program. And while you're out there in search of more web-based goodies, check out Houston We Have a Podcast, where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday, and today, Pat Ryan continues a special series on NASA's Human Research Program, this time with a discussion of the current preparations to build the sick bay capability for Orion and the other spaceships of the future. These include things like figuring out how to utilize a limited space for supplies, and how to teach a crew how to care for themselves when they're too far away from Earth to get help. Go to nasa.gov/podcasts for today's episode, all of our previous episodes, and the full library of all NASA podcasts. You can listen to any of the above on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control Houston.